Wow. Hello and welcome everybody to FyneConf 2019. It is so exciting to be here and to present our very first conference dedicated to the Fyne Toolkit, its community and all the projects around it. We've got a packed few hours for you coming up today. And well, let's just get started with a little outline of the day to come. The schedule should have been available on the website. We hope that you've had a chance to look at it. We're going to get started shortly with an introduction to Fyne, a reminder of why the project exists, why we think it's important that a project like this is supporting graphical application development in this day, and what is new. After all, we did organize this event around the 1.2 release, and there is a lot of exciting things to share with you. Don't forget at any point during this session that you can tweet questions to us. Do use the FyneConf hashtag if you're wanting us to get notice, and we'll try and answer questions as they come. We also have the YouTube live chat available in the browser, and if you're on one of our Slack channels, then please do talk away there. We have many of the Fyne community available today to help out, and we look forward to answering any questions that you would have and adapting our content to fit that which is going to be interesting for those tens of people who are watching us now. Now, before we get started, I just wanted to say a couple of thank yous to speakers and support that we have available today. My name is Andy Williams. I started the Fyne project last year, and I'll be talking through the welcome presentation, our introduction, getting started, and the what's new section this morning, and then concluding later on today with the release information and our roadmap going forward. Stephen Houston is joining us from the USA. I'm very excited that he is going to share with us in a couple of hours' time the status of our FyneDesk project and where that is going. So if you're excited about the Linux desktop and a new approach to that, then do stick around. Steve O'Connor, another of our core contributors, has helped put together the presentation on fun and games with Fyne. Unfortunately, he isn't able to join us right now, but we are going to be able to patch in some of his presentation a little bit later on. And also a thank you to Scrivito, a SaaS CMS platform based in Germany, who have kindly sponsored our Q&A session later on today, which will be held on Google Meeting. Everybody is welcome to join us there. It's the only portion that won't be live streamed through Twitter, but anybody who would like to get involved is welcome to do so. Just a quick reminder also, we're going to run the getting started and what's new section, followed by the fun and games. There'll then be a short break for people to catch their breath, and we will follow on with a second live stream URL, which you can find on the website at conf.fyne.io. Excellent. Well, let me take this opportunity there to speak through the vision and the background of the Fyne Toolkit for anybody who hasn't caught one of our presentations before. The question that I think it's important to start with is, why do we need a new GUI toolkit at all? Well, there's any number of reasons, but I think these are the top ones that motivated the decision to start this project in the first place. For anybody who's familiar with coding graphical user interfaces, these problems may be familiar. And for anybody who's worked through web technologies or is new to this area, it may not matter quite so much, but these are the main areas that are worth learning from when thinking about how to go forward. A graphical user interface is something that has been around for a very long time, and it has evolved a number of times in that period. However, the toolkits that we have available now, especially on the desktop, are really built on legacy languages and technologies. It doesn't take long before you realize that many, even of the newest adaptations, are based on a C language project or binding underneath. That may not be obvious initially, and it may not even matter to start with, but after a while you realize that things like the memory management, the thread management, and other aspects of object lifecycle creep through into whichever language you are using on top of it. And so it means that without taking a fresh approach, starting from scratch, you're going to be in a situation that is held back by the choices of many years before. Another challenge that we face is the steep learning curve. It's not as easy to simply write your first graphical application as it is to create your first web page, to perhaps write a command line application, or to put together other applications based on more modern tooling. And so this is a challenge to people getting into graphical application development for the first time. In this area, it would be very beneficial if the tooling and documentation was slick, easy to understand, but unfortunately that's not always the case. Some documentation can be hard to find or hard to read. It may not be integrated into your development environment. And even in the situation where the documentation, examples and tools are fully featured, it may not be straightforward to get them installed. There are certain packages which are so large that your hard drive may struggle to get up and running just to display a Hello World application and understand the code underneath it. And all of those said, it's still exceptionally difficult to well support multiple platforms. A lot of the better technologies and toolkits around at the moment target specifically one or two platforms due either to their similar nature in terms of the hardware or because of the commercial aspects. One company may be pushing one platform and they would like integration across devices on the platform, but not quite so much for anything outside that ecosystem. And so even with technologies that are capable of cross-platform deployment, it may not be as simple as we know it could be. And so thinking about all of these elements and looking at the landscape of what was available, it was decided that there was a real opportunity here for a brand new toolkit that could address these concerns and make the graphical user interface landscape a lot more approachable. We hoped that by taking this avenue, it may become a lot more easy to build applications for desktop and for mobile. That would mean that even the very beginners would be much more able to write their applications and distribute them. And also, this is an opportunity to show that application development native on desktop and mobile is capable of being built quickly and easily so that we can achieve the speed and ease of use that a native piece of software can without having to adapt it from web technologies or other areas that have perhaps not quite the right design for this piece of software. And if we got it right, maybe we would even see more open source graphical applications out there, either looking really great or just being much easier to get involved with and to improve over time. And so we thought it was time for a new solution, a Fyne solution, if you will. Our aim is to be the best toolkit for easily developing beautiful native graphical applications across all platforms. I think that speaks volumes and encapsulates what we're all about, and everything that we talk about today will tie back to this ambition. And when we say all platforms, we really are going out there to try and reach every platform where a graphical application makes sense. So if your device has a screen, then that is something that we want to be targeting and helping people to build great software for. So what does it look like when this is done well? What does a good toolkit enable? In our opinion, it is really important that such a new technology is self-documenting, so it's really easy to learn, easy for the documentation to be found and understood by anybody who is familiar with the technology, the language, or not. And it needs to be idiomatic with the language it is built using, meaning that everything that it does is consistent with the way that the language is designed, so that libraries built outside of the toolkit will work really well, so that functionality is discoverable and easy to bring in to an application built with the toolkit. We want a clean and simple architecture, something that is no more complicated than it has to be. In fact, all of the difficult aspects of building a graphical application should be well out of the developer's concern. It should be handled completely transparently so they can get on with building their application. Thinking about how it's designed from an end user point of view, we liked the way that the material design was approaching interface design, the recommended approaches, the iconography, the clean palette was very helpful. And of course the fact that Android users recognize and understand this, and in fact anybody who uses Google software on the web or iOS as well would be familiar with the design language. And additionally, they have taken an approach to use vector-based graphics, which matched our understanding of how to build a graphical toolkit in the modern age. When using vector graphics, we are able to adapt the user interface to any scale so that we can have a great looking output on small devices with a low pixel count, handheld devices where there's a huge number of pixels, all the way through to perhaps a television where it's a massive screen, but again the pixels aren't great. If you can scale very efficiently and have beautiful graphics at any resolution, your applications won't suffer on any of the target devices. And also, we wanted to offer both light and dark themes to provide a consistent user experience across all of the applications. So this means that somebody running a Fyne application could decide whether they prefer a light or a dark theme to their desktop or to their applications, and this would match the system configuration that they have set up on their device, but that whichever they choose, the user experience would be clean, it would be very easy to understand how applications were working, and they would instantly be able to pick up these applications and get to work using the main functionality with no trouble at all. And at a technical level, no runtime dependencies were absolutely critical. There's a lot of good software out there which might require that you install libraries or bundle libraries with your applications, which makes need for installation systems, package managers, and we thought application distribution needs to be so simple that somebody should be able to just copy the application onto their computer and it will work, no matter what system that is. And so those are the principles that we used when designing the Fyne toolkit, and we try to stick to them at all times. There is a widget demo which demonstrates all of the functionality available in the toolkit for anybody who hasn't seen it yet. This is the widget page of the demo. You can get it using the go get command at the top of that page and tab through it yourself. And this also, of course, comes in a light theme as well. And why don't I just load that and we can have a look. Excuse me one moment. There we go. Unfortunately, I had some settings set up that weren't ideal there, and I noticed, unfortunately, the URL here mentioned Fyne settings. It should be Fyne demo. That's a little bit of a spoiler for later on, but we'll check that out shortly. So this is the home screen of the demo app. It's designed to show the capabilities of the toolkit and also as a learning aid. So anybody who was looking to build a Fyne application, if they were struggling at all to find the features that they wanted, well, they could come to this application, see them in use, and then, as with the rest of the toolkit, the source code is readily available. So they could look at the code, how it's utilized, and then be able to incorporate that in their application. So the widget demo here illustrates how each of the pieces of functionality render. We've got buttons, input fields, as you would expect, select boxes, sliders, a variety of progress bars, and there are things that will help to lay out your application, such as the form, scroller, and also an image scroller. If we look at the graphics tab, you can see what's available at a lower level than the widgets. These canvas objects are the drawing primitives that a Fyne driver implements to be able to draw your application to screen. You can use any of these in your application, but as you'll notice, they don't match the theme because they are just basic objects. And the widgets that utilize them apply the theme to them. There is also a selection of icons available from the material design icon set that you're able to use in your application however you would like. And then we can look at some basic window handling. We have dialog boxes, including a progress bar. On the right hand side, we've illustrated how different layouts can set up content for your application. And also it's possible to open different windows, and this one is a fixed size. This one appears centered on a different screen, but there you go. And an advanced tab, if people want to get into more complicated functionality, you can load a custom theme, you can inspect how keys are being handled, and also test out full screen mode, which is excellent when you're not in the middle of presenting. Okay, so that was a run through the functionality of the Fyne Toolkit as it exists. I hope that was useful to everybody listening, and if you're familiar with those things, not a problem. I'm hoping that it's been useful to you so far, but let's make a change and head into what's new. After all, I know that a lot of people were excited to see when this 1.2 release would come about. So let's cover what we've been working on in the last few months and are excited to share with you now. Mobile support. It should be no surprise the 1.2 milestone was entitled Mobile Support, and we're very excited to say that it is here. As you can see on this slide, we have 3 images representing the devices that we've added support for. On the left hand side, it is the Fyne demo application running on an iOS device. This screenshot was taken and saved, so that's why the borders aren't round it like it would be in the simulator. And one thing you might notice is that the toolbar from the demo application is on the bottom of the screen. Some of the widgets are deciding that on a mobile device behavior would be slightly different, and so it matches the user's expectation. You might notice also at the top left of the screen there is a burger menu button which would drop down the menu that your application had configured. On the top right of this slide is a screenshot of an Android device, which looks very similar to the iOS one. Obviously, they are both mobile devices, so the Widget Toolkit is adapting them very similarly, but you'll notice the padding is different because it's adapting to a slightly different environment. The hardware may have notches on the iOS, where perhaps the Android device didn't, and so the application is fitting within the visible space for your device. And then lastly, it may not be a mobile device, but the Raspberry Pi was included in our supported devices for this release. That is due to the nature of the rendering technology. In fact, the Raspberry Pi uses the same graphics stack as the iOS and Android devices, and so we included support there. What you see in that picture is a touchscreen device that was available cheaply from your favorite online store, connected to a Raspberry Pi and the software built and loaded directly on it, and it works perfectly as well. So what does that mean for the tools themselves? How can people use this new functionality? Well, the exciting news is that the code you write is just exactly as it was before. There are no new blocks of code required to check how the device that you're running on is shaped. The toolkit is going to do all of the heavy lifting for you, and your application will just run as expected. We have added a mobile simulation mode as well, which will be very helpful in working on your applications before you even have to worry about packaging for mobile devices. It's in a tag called mobile, and you can simply run that on your existing code base with go run -tags mobile and then your source code, and that will load a mobile simulating window on your desktop. So this is external to the iOS or Android simulators and emulators. This is purely for debugging. It will run in a device that configures itself like a mobile device, and should be a first point of call if you're thinking about working on these new new devices. Also, we have added iOS and Android operating system types for the Fyne package command. If you've not seen the Fyne package command before, no worries at all. We will be exploring it more later. But as you can see in this last command on the slide, packaging an application for your Android device is as simple as using Fyne package-os Android and the files to include. And that will generate an APK file, which you can then install onto your device or could process and upload for distribution. So that is getting your application ready. How might this new functionality be made available if you do want to learn about the device that you're running on? So we have added some new APIs that help to explore device capability. It's not something that we would recommend doing by default because, as I said, we're aiming to have applications that run absolutely perfectly across all of the devices that we support. But if you want to, you're able to find out information about the device. You can look up device information using the find.currentDevice helper function, or if you have a reference to the loaded driver, it has a device function which will return the information that the driver is currently running for. However you get the device value, it will conform to this interface, and so you can inquire as to the orientation of the device, which would be portrait or landscape. Is it mobile, and does it have a keyboard? Now, the definition of a mobile device may be a little obscure, but currently if it's something that you hold in your hand and walk around with, we're calling it a mobile device. So a smartphone, a tablet is, but the Raspberry Pi currently isn't. The has keyboard is probably much more interesting. That is going to return true if a hardware keyboard is available and false otherwise. That becomes very useful if you would like your user interface to adapt to a touchscreen, if you feel there's a benefit to not having to pop a virtual keyboard up, but instead taking touch input yourself. And we'll explore an example of that a little bit later on. Wow, that was mobile, and I hope that we can check it out a little bit more later on. However, that is not all that we've had added in this release. So let me just show a couple of other things that we have added to this update. Custom widgets. So it has always been possible to write your own widgets for extending your application to do things that aren't supported out of the box. But it wasn't really that easy. A lot of code had to be written, and we wanted to make this much more approachable. And so we have added a new type called base widget in the widget package, and that will handle all of the basics for you. We'll show how that can work later on, but essentially it is taking care of all of the elements of being a widget that aren't specifically the functionality that you might want to be adding. This makes it much more easy to create custom widgets, much less code, and also far fewer potential challenges if this is a new area of code for you. The great benefit to this is actually it makes it much easier to extend existing widgets. Now, there have been a lot of feature requests to add functionality to one widget or to another, and we've not always been able to say, absolutely, that's a great idea. Sometimes it sounds like that might be specific to an application context. And so we have said on occasion, that's something that you might need to take care of yourself. And so in this situation, we're making it much more straightforward to build on the widgets that exist. And examples being where you might want an entry that handles certain keys, or you may want to add certain functionality to an icon, such as tapping it. These are all really straightforward now. There is a new function on the base widget called extend base widget, and if you include that line of code at the beginning of your constructor, then everything should work as you would have hoped. As well as custom widgets, we wanted to provide some storage for your applications. So we've made it possible to do exactly that. To utilize the Preferences API, we're needing a new application instantiation called new with ID. This means that you pass a unique identifier in as the beginning of your application so that it knows how to store preferences uniquely for yourself. This ID might be familiar to people who have programmed iOS or Android before, where you declare your unique namespace, and this would be the same as an application identifier if wherever you were publishing required such information. This functionality is made available through the Preferences function of the application interface, which everybody who has built a Fyne app before will have used. It's the very first line of code is to create your application, and their preferences is available right away. Each type of value that can be stored, which is currently string, boolean, float, and integer, has three functions that you can see on this slide. Using string as an illustration, you have the string function, which gets the value of a stored preference, where key is the identifier for that value for your application. String with fallback is a helpful function if you would like a default value to be provided if none has been set. The first function would return the 0 value, whereas the second would provide the fallback value that you specify. And then lastly, there is the setter, which uses the key that you give to store the value in the second parameter. That is pretty straightforward, but hugely useful for any application that needs to store state, but doesn't want to have to manage storage or load additional libraries to do that. Also, we have support for the playground. Now, this is something that people have requested for a while, and we're very excited that it's now possible to render parts of your application in the Go playground. We've provided a new package within the tools package called Playground, and that provides these three methods that you see, which allows you to render a window or a canvas, which is the content of a window, or just any canvas object directly to the Go playground. The last function being the most useful for debugging, you can pass a primitive canvas object like rectangle or text, but more beneficial is that you can pass containers and widgets and parent widgets. They all conform to canvas object, and so the render function will be able to display the contents of all of those in your playground window. and we will come back to that later. Lastly, for the functionality that's been added to the toolkit, we've improved the package and installation process for your development. Just like other Go apps, it's always been possible to run a Fyne application using the standard tooling. Go run myapp.go is just exactly what you're going to expect. It will run your application, load any, show any windows that you've defined, and run like any other. However, this is different when you look at graphical application distribution, because we don't really want to just share a single binary file. It wouldn't have the right icon, it wouldn't necessarily be in a place that application launchers expect it. And so we need to package applications. This will take an icon and various metadata files around and bundle them together. This has been improved in the 1.2 release so that the commands parameters such as icon and data are optional and sensible defaults are provided, so most of the time you don't need to manually specify these parameters. And of course we have added the Android and iOS support into this package command, so as well as packaging for Mac, Windows, Linux using this command, you could create your Android and iOS app bundles as well. And finally, we added a new subcommand called install. If you're on a desktop environment and you would like to have the application you're developing installed into program files or the applications folder, you don't have to do that manually anymore. After packaging, simply call Fyne install and the package, and it will make sure that it is wrapped up with all of the metadata and installed into the correct location for the type of platform you're running on. And that is pretty much the functionality available. However, we have packaged one new application with version 1.2, and that is the settings UI. This bundles with a new global persistence of the settings previously made available through environment variables. So users are now able to specify the theme that they would prefer and how they want the application to scale on their screens through a central location which is saved, and they don't have to worry about managing environment variables anymore. And we will look at the settings application in real life a little while later with some code. But just before we move on, let's not forget the hard work that the team put in to all sorts of extra functionality in this new release, including horizontal scrolling, a vertical display for tab container. We're adding pop-up menus to the entry widget, diagonal gradients which can come in handy. We've also optimized rendering for the desktop apps so that things work a lot quicker. We've squashed lots of bugs, and we have managed to work on some of the memory leaks that were found by some community members following previous releases. This is a big release, and we're really excited to share it with everybody here. Now, that's a lot of talking. I think that it would be great to write some code. Let's have a look at building our first Fyne app. So we're going to build a Hello World application. It may not be particularly inspired, but it really is a great start. And I think that you will agree, this code is pretty straightforward. I think it is one of the shortest Hello World graphical applications for native apps that I've seen. I'm not entirely sure how it could be clearer, but let's work through it and understand the code itself. here we have our editor. So we are going to go through that code line at a time, but first of all we need to open a new file. I'm just going to work from the terminal built into our IDE here. I will move to a temporary storage and create a new project. From here, let's create a new file called ui.go and open that. And here we have our brand new file. As with any Go executable, we need to set it up in the main package. We don't have any need for additional packages here. This is going to be quite a straightforward application. And then we need to set up our entry point, which is the main function. Okay, so we have our Go app that does nothing. So we want to create a new Fyne application, and so we start by calling app.new. And there it will import for us the app package of the Fyne Toolkit. This is your entry point into any Fyne application. That package does a lot of clever, complicated work to determine what device you're running on, how applications should be configured, and provides a lot of implementation for the operating system it's going to be running on, which of course is detected at runtime, not during compile. We like to use A for application and W for window. We type it a lot and it's pretty straightforward, so I hope that convention isn't confusing. Let's create a new window. A new window there takes one parameter, the window title. And now that we have a window, we should put something in it. So we will set the content of our window, and that's going to require a canvas object. This time, let's just put a label widget in it. So for that, we use the widget package, which I will just import so that we get our suggestions. With that imported, we have all of the suggestions available to us. Let's use a label which takes the string content. And so we have created our window, set some content to be a label, and before our application will show anything, we need to show the window. Now, you could call window.show. However, because this is our first window, we need to make sure the application runs as well. Now, we could show the window and then run the application, but let's just call show and run, because that will do both for us. With that loaded, we can go here and go run ui.go. And there we have it. This was our first Fyne application. It has been pretty straightforward and loaded on the first run, which is always great. Now, as with any Go application, you could, instead of running, you could choose to build it so that it could be run over and over again. When I do that, you can see that there is a new file called UI, which is our application, and that can be run directly. Now, I mentioned earlier that every Fyne application supports multiple themes, and I mentioned that we have a new settings application. So let me just bring in our settings app. Now you can see my preference is for a dark theme, but if I choose light instead, our preview there, we apply it, and you can see our application with no code at all has updated to the light theme. Additionally, you might notice a scale value. This is a floating point value that represents how big we want the items across our application to be. If it seemed a bit small and we wanted larger text and graphics, we could perhaps say 1.2, and everything grows a little. If you were targeting, for example, a kiosk application or running on a super high definition monitor, you could set it to a value of 2, which is getting pretty large. Or if you would like your windows to be the same size across all of your screens at an appropriate value depending on the density of its display, you could set it to auto, and then it would be consistent as you drag from one screen to another. However, for most systems, they have their own scaling. Mac and Windows certainly do a really great job of setting this up, so a value of 1 makes sense for most people, especially during development. And I'm just going to pop that back to dark because that is my preference. Lastly, I mentioned that we have a new simulator for mobile, so we could go run tags mobile UI.go, and that is going to load our application in a very different configuration. Don't worry about the output messages there. There are pieces of work ongoing in the Go compiler that make mobile work better. And here you can see a portrait mobile device simulated in a regular window. It's chosen the light theme because mobile devices have a different way of determining which theme they should use. It's not a global preference that Fyne would save. It is defined by the operating system, and more often they go with light by default, so that too is what we've done. There isn't really a lot to present there, but hopefully that mode will be very helpful for you. Now, if I jump back to our presentation here, we have explored the Hello World example. We have seen that it is really straightforward, a simple app with minimal code. We're able to build it or run it, and it will adapt to the built-in themes, the user's preference, and the scale of the output device, or again, the user's preference. And we have seen it simulated in mobile as well. Now, let us move on, and we could see this working in the playground. We can largely use the same code again, but we do need this playground tool to be able to show the content. Now, if I can bring up the Go playground here, this is a local version of the playground that I'm running. This will work on the regular playground. There's nothing special about the code that I'm running here, except that it is hooked into the Fyne release that is not yet publicly available, and so that's why I'm having to run it locally. As you can see, this is again a widget, a label widget, which we can set to contain hello FyneConf. And the new package that we saw in the slide here, the tools playground package, is used here to render this widget. So if I click run and let it build the app for streaming through to the playground, we should be able to see the same content as we would expect in a window. And there you go. It's using the same dark mode that we saw in our applications by default, and it has taken the content, saved it into a format that the browser can view, and streamed it back as a result of the compilation. Hopefully this will be very helpful when learning about code, layouts, or how to set up your widgets, and you don't want to run an entire application every time, but also you don't want to write a new small application just to accommodate the test that you're working on. I think that I will leave the playground there. Any object widget that works in a Fyne app will be able to be rendered here, but I don't think we need to go through every one of them to show that. And whilst we're writing our Hello World application, we could package it for installation or for distribution on another platform, and also we could install it. So let us look at this new functionality as well. So we have our Hello application again, and that's going to be possible to package using the Fyne command. Now, I've previously installed the Fyne command using this command at the top of the slide. Go get the Fyne command. So we could run that, but it's not necessary here. And that's fetching the Fyne command from the Fyne repository on GitHub. But I will just use it here like this. Fyne package this project. And we're seeing, like I said before, that the defaults are being used if you don't specify specifically which icon you would like to use. So we could use a specific file like that, or I could copy a file in. Now, why don't I just copy the Fyne logo? So we can now this may be an issue with the modules configuration. Apologies. Well, in a situation where the package doesn't do what you're expecting, and this does sometimes happen with small one-off projects, we can build it apologies, and then package it. Now you can see I have a new folder called hello.app. So if I open this containing folder, you can see that corresponds with this icon here, and if I double click the icon, there you go, it's running our application. Very exciting. And if you wanted to go one step further and install it, you can see there's currently no Hello application installed. But using Fyne install, the Hello application appears in our application launcher. How exciting. And if I load an alternative target, so let's say we wanted to package for Android instead. The same command is going to go away and build our software for the Android platform and produce an APK file. Now I will leave that be. It's probably got a lot of code to work through, and we'll come back to it later. Sometimes the compilation of an application can be slow. This will usually just be the first time that you compile for a new target operating system. And I was about to move on, but I can see that it has in fact already completed. We have our hello.apk file there ready for distribution to your Android device, in which case you would use the Android debug bridge to install hello.apk onto your Android device. Now, I happen to have an Android device plugged in, and it is now letting me log on to the phone. And if I just switch over to my camera, I can show you this is our Hello World application that we just built, now running on our Android device. Wasn't that straightforward? And you'll find that building for iOS is almost exactly the same, with the additional step of certification, which means you need to sign up for the Android developer for the Apple developer account and get a certificate to be able to build 4 devices. So we won't step through that right now. Oh goodness. Apologies. So there we ran through packaging. I was going to talk about writing tests as well, but unfortunately that is us really on our time limit. But I'll leave this code on screen just briefly to show that unit testing with Fyne really is as straightforward as unit testing any other Go application, and highly recommended. We start a new test case. In this instance, I've created an imaginary application called a greeter, which would have an entry, that's a text input field, a button, which I've called welcome, and when you type your name in and tap welcome, an output would be to say hello, your name, and our unit test here is able to say type the word name into our entry, tap the button, and then check that the text is hello name. If it's not, then the test should fail. That's pretty straightforward, can be run using the standard Go tools, and is going to execute and test the application in memory without running anything on the screen, which means it's very fast and very easy to run. And cross-compiling is perhaps useful if you don't have tools for building to all different architectures on your desktop. Now, this might be the case if you don't have Mac binaries, the Xcode SDK installed on your Linux or your Windows device. As we're building graphical applications, these are required to build and not necessarily straightforward to install on lots of different platforms. So the FyneConf project was created by Luca, one of our core contributors, and this means that you can run builds for platforms that you don't have the tools for locally using a combination of Docker images and installed compilers. If you're thinking about building for lots of different platforms and you don't have the tools yourself, I would highly recommend checking out that project. And with that, I think we have wrapped up our getting started. I will potentially talk more about extending and creating custom widgets a little bit later on.